This is a special episode of the Immunology Podcast, IUIS 2025, Day 1. Hey everyone, this is Dr. Jason Goldsmith and Dr. Brenda Rad. Welcome back to the Immunology Podcast, where we have conversations with immunologists. As you may know, yesterday launched the start of the IUIS 2025, the International Congress of Immunology in Vienna, and Brenda and myself and the Immunology Podcast team are all attending. Drop by the Immunology Podcast booth number 3 in the exhibit hall to play some games, win a prize, and find out how you could be featured on an episode of the podcast. We're also very excited to be hosting a live show here on August 21st. Join us for a conversation with Dr. Zwi Burnman to learn about his work on mRNA-based dendritic cell cancer vaccines. If you can't make it, the episode will air on August 26th across all our platforms. Today and every day throughout the meeting, we'll be releasing these special episodes discussing our favorite sessions of the previous day. So if you weren't able to attend, we've got you covered. We're going to be kicking things off in just a moment, but before we get to that,
looking for a simple way to isolate immune cells? Visit STEMCELL Technologies at booth number 5 to request your free EC subsample and discover a versatile immunomagnetic technology trusted by researchers for over 20 years. With no columns, minimal steps, and high purity results, EC Sub is the easy choice for simplified cell isolation. Learn more and get your free sample at stemcell.com/the easy choice. You know what's an easy choice? Also,
what?
Enjoying ourselves. And Vienna, how are you doing?
I'm doing pretty well.
Yeah? How's your jet lag?
I'm mostly recovered, actually.
Nice. Yeah, you've been here for a while. You also were in the neighboring country of Switzerland, and you did not bring me chocolate. He says they melted on the way, but I have my doubts.
Right, they did melt. It's kind of sad.
You ate them. And you don't want to admit it, but that's okay.
I ate one. and then the other 7 became another one.
All that tasty milk chocolate from the Swiss Alps. That's okay. I'll have to go get it myself. Thankfully, it's not. It's just a train trip away for me. But enough of that. We are now in Vienna. This is kind of day 1, but kind of day 1 after day 0 of the meeting. We also attended some talks yesterday, but it's been very exciting. The place is really nice. A bit removed, but it'll work. And there have already been some cool talks and some cool things to see. So why don't you start up and then let me know what your highlights were, and I'll go into take over.
All right. Well, I on Sunday went to some of the German Society for Immunology satellite meeting. And this is pretty good. It was a mix of kind of experience levels presenting, and the one that was really cool to me, with all of my inborn bias, is a talk on harnessing NK cells against solid tumors by Adelheid Cernwenka. And it was about they used a CRC, patient-derived organoid platform, so they can take cancer, colon cancer cells from humans who have, colon cancer biopsies and drive them to organoids. And then they can use that for a variety of different things. So what they were able to do is they were looking at NK cells in this case. And so they did NK cell co-culturing, which mimicked what happened with patient-derived NK cells, particularly with hypoxia signaling. And so they were able to see that what they saw when they threw NK cells on top on these models really phenocopied what they would see from NK cells in actual tumor tissues. That was the first step. Like, hey, do we have a model that's useful? And then they started probing some things. So I think the first part for me was they could make a model that worked and that replicated human activity. And then what they were able to do is then they deleted HIF2A to get rid of the hypoxia pathway, and that improved the killing. And they were also able to see, in this case, that activation of NK cells in this system modeled what they saw with a tissue-like phenotype in the tissue cells. So long-term, this is showing like, hey, now you could potentially screen drugs in this model instead of knocking out HIF2. You could screen drugs that suppress HIF2 and see if that enhances cancer killing, and then have a pretty good justification to get into at least mice or hopefully people more quickly, because the model's phenocopying what you'd expect from a disease state in patients. So that was neat. So then next, in the same talk, there was a circuits of inflammatory memory by, I'm going to butcher it, Trontafios Chavakis. So this was an interesting talk where they were looking at how immunity develops with memory. And so they were looking at trained immunity they were starting to recognize is initiating the bone marrow by rewiring of myelopoiesis. So, we know memory like, oh, hey, this B cell has a specific antibody or antigen target, but this is more of a general immune pattern response. And what they found that was really cool is a lot of this is driven by epigenetic rewiring and that the comorbidities are linked to the disease. So, for example, periodontitis, which is gum inflammation, is a comorbidity present with inflammatory bowel disease, diabetes, and other inflammatory conditions. And they found that it's known that treating periodontitis reduces your blood sugar in diabetes. So fixing the comorbidity fixes the initial condition. And this is driven by epigenetic changes. And at least in the mouse system, you can BMT, bone marrow transplant stuff, and get transfers.
Wow.
Yeah.
Interesting.
Yeah.
Okay.
So that was fun. And then today, we were in most of the same talks. So maybe for part of this, we should just talk back and forth. Mm-hmm. So for those who aren't familiar with the conference, there's kind of this sandwich approach where the morning is sub-sessions, big chunk of the afternoon, everyone's together, and then you break off again for plenaries in the evening. And so we're recording this after, yesterday's pre-day and today's day up before the break-off plenaries. And so we were both in a couple of really cool talks together. Mm-hmm. The keynote was Shimon Sakaguchi from Japan, who was looking at how you can convert disease-mediating T cells into Tregs. This kind of approach. So, but what I thought was cool is, we all know, memory and effector T cells are telling our body to do bad things in case of autoimmunity. If only we could turn them into FOXP3 Tregs, then instead of the attack signal to that antigen, it's going to be the chillax signal to the antigen.
Chillax. And
so he started with like, how do you do this? Which is like understanding the Treg type DNA hypomethylation patterns and what makes a Treg besides just I have FOXP3. And he was showing that FOXP3 is not early in the process, but relatively late. And there's a lot of hypomethylation, for instance, that occurs in natural Tregs that's stable. You talked about a CRISPR screen for FOXP3 regulations that regulate in induced Tregs. And then looking at a chemical screen for induction of FOXP3 and CD4 and CD8 cells. And so from there, what did you take next, Brenda, from this awesomeness?
Yeah, I mean, for those who are in the field, Shimon Sakaguchi is one of the fathers of modern Treg theory, and he's well known for having really put regulatory T cells back in the map in several years ago. And I think it's really interesting, this idea of the difference of being able to bring conventional cells into Tregs, because there's always the question is, are they going to be stable? And as you mentioned, one of the epigenetic markers of stable regulatory T cells is this hypomethylation specific areas. He's now showed that there's about there's around 300 regions that are especially demethylating in kind of bona fide Tregs from the thymus. And this is only about less than a fraction of a percent of the total methylated regions at any given point. And these are genes, FOXP3, GITR, CTLA4, EOS, CD25, they are all having a highly hypomethylated promoters. And so the question is so usually we consider that if you have peripherally induced Tregs, they don't have this kind of signature. But what he showed is that there are several ways in which you can induce more stable, they call them stable phenotype, or I forgot the exact name, stable induced Tregs. And they show a few ways in which you can do that. This screen that you mentioned, and also if you have a stimulation in absence of CD28 co-stimulation, that also seems to induce this hypomethylation and generate Tregs of a stable phenotype that can be transferred. And also he had chemical compounds. But I think that's I'm very curious about that, the idea that you can actually make true stable Tregs peripherally, and you can make them based on starting with conventional activated cells in autoimmunity or inflammation. That is wow, I'm pretty impressed that's what he could show. So very, very cool talk. And of course, whatever Shimon Sakaguchi says about Tregs, people listen.
All right. So then after this, we had Rising Stars. Mm-hmm. All right. There were three. What was your favorite rising star to start with to present first? And then I'll do another one.
Well, I really liked the presentation from Marion Brunk because she is I think a good, well known by me, and she's a PI in Monterrey in Mexico, and she talked about the production of leukocytes that you find in breast milk, and how chronic inflammation, for example, from obesity, can permeate into the milk and can affect the kind of immune cells, because there is cells are in, especially in the colostrum, the breast milk, the early breast milk, and that you see this, for example, B cells, like sizable population of B cells, but that this kind of B cells, their phenotype changes when you have obese mothers and their milk, and kind of hinting at the idea of a larger idea that really breast milk is a very important reflection of the immunological state of the mother. And, I think that's only going to get more and better understood. And I think that we had also the talk later on from Yasmine Belkaid. She also spoke about maternal breast milk and the production and the development of mammary glands, and what is the role of the immune system in that. How about you? Which one do you want to highlight from the Rising Stars?
So going along with obesity as our thing, right? Fat on the frontier, fueling the immune response to chronic infection which was Matthew Sinton in the UK. So one, this is trypanosomiasis, which he was looking at. And that's what my wife worked on in grad school. So that was cool to catch back to. But then they found that when you get this disease, you have a bunch of IL-17 that goes on. And if you knock out IL-17, parasite control goes to crap. But they also found that the IL-17 drives weight loss and adipose tissue wasting, probably because that's some of the tissue where there's a reservoir of the bug.
Yeah.
And so IL-17 is important for weight loss. So now you have inflammatory cytokines that relate to your waistline. Waistline cytokine.
Waistline cytokine. These are... Okay. And that's very relevant to today's day and age, isn't it?
Hey, what are you saying?
Well, no, I mean, just in general. I'm not pointing fingers anywhere. I'm not pointing fingers.
All right. So that was that one. And then I guess the other one to finish it off was from George Robertson, also in the UK, with the interferon nexus, sex differences, autoimmunity, and cardiovascular disease. And they were using lupus as a model system. And this is especially early onset lupus. And then they were really kind of deep dived into how X inactivation may have a role in lupus formation in females by how much type 1 interferon you're driving.
Yeah.
And that they're seeing now with a growing, public openness in the trans population, they're seeing that when you give exogenous hormones, it's phenocopying the hormone they're given. So these are sex hormone-driven changes. And then that the modulation by the X inactivation is another secondary layer. So they're starting to get at why there's some sex differences for all these autoimmune diseases and also cardiovascular disease, right? Just driven by the immune system. And the two big ones are X inactivation,
right?
And what that's doing, because that modulates how much dose you have in women, right? Because they have two X chromosomes, and you don't want two of your chromosomes doing all that work. In
particular, TLR7, which is there's the pattern receptor that is encoded in the X chromosome. So women tend to have more of it because sometimes that gene...
You don't get full silencing. In yesterday's talks with the German Society, there was multiple talks on TLR7 and lupus.
Yeah.
Like 3, all about it.
Yeah, indeed. I mean, I think by now that's pretty well established. That TLR7, different doses due to incomplete chromosome X silencing. But I think it's really important, no? Because this is also this is pediatric, right? There's a lot of these some pediatric also presentations from many of these diseases. Okay, so I think the last talk of today, Yasmine Belkaid's talk, was really nice. Also, it's nice to see. So Yasmine Belkaid she's originally French Algerian, and she had a very illustrious career at the NIH. And I think last year or so, she actually moved to Paris, and she's now the president of the Institut Pasteur, which is, a very well considered, very prestigious institute in France for immunological research and other kind of biomedical research. And these people, they know where to, when they get into a field, it just explodes. And she was talking about the development of mammary glands in what is the role of leukocytes, so lymphocytes, in allowing this important remodeling of the tissue and the presence of these alveoli where the milk is made. And then, you need this space, and you need this complete reorganization of the tissue. And what she showed that there's this population of cells that are highly expressed in Tibet. They are double negative cells, CD4, CD8 beta chain double negatives, and they are kind of reminiscent of CD8 alpha intraepithelial lymphocytes that you find in the gut, and they express a lot of granzyme A, and so they named them mammary intraepithelial lymphocytes, and they show that their presence depends on IL-15, and then they are produced during pregnancy as part of the changes that are observed in the thymus. There's this thymic involution that is happening during pregnancy. Apparently, during this time, the output of these cells increases, and these cells are very important to sustain and to kind of guide this remodeling of the tissue of the mammary gland, and is really important for the quality of the milk and the amount of milk that is produced. And so I thought it was really cool how they find this new type of cell that is really specific of the mammary gland and really important for lactation, and they're going to start developing during pregnancy. So I think I see so much future research on, this pregnancy, and there's going to be so much more coming because it's such an important time. Also, immunologically speaking, it's so complex. There's so many things going on.
It is interesting and long overdue in terms of being studied.
Absolutely. Yeah. I think long overdue. That's definitely the thing here. And so I also want to talk about this morning, because you were in there, Jason, and I was there. There's a really cool talk from the European Research Council talking about ERC grants, and a really nice introduction to the starting grants and the synergy grants, and what are the kinds of funding options that are available for individual researchers that want to get funding. This will be kind of the equivalent of an NIH grant. You can get 1 million, 1.5 million euros as for your personal project, which is pretty nice. And they are so interesting in terms also of promoting, international cooperation, and also you get all this professional funding that you can take with you through institutions. And I thought it was super nice. I think we should definitely invite them over to the podcast to kind of talk about grants in Europe, because I think that oftentimes it's a bit confusing, also because every country has their own national funding opportunities, of course. So it's nice to know also that from a higher place, there's also from the European level, there are a lot of opportunities that I think is important for early career researchers to know, especially for the starting grants, for example. They are available between 2 and 7 years after graduation from your PhD. And then you have consolidator grants that are meant for after 7 years, I think 7 to 12 or something for the exact limit. And they are meant to kind of go with you through your career and allow you to establish your own independent science. And they are really career makers if you get one of these grants. And I thought it was really nice overview. And this was organized by the junior community, IUIS junior community. So kudos to Anne Han, who is the president of the community at the moment. And they're doing such a nice job organizing events and kind of networking. So that's been nice to get to talk to them. And and also they invited us all today to talk about careers and science and communications. So it's also very nice. We had fun, right?
That was actually really fun. It was a really good, well done event, actually, I think.
Yeah, that was really nice. Anything else you want to share from today?
And that's it.
Yeah. Did you like the schnitzel you had for lunch?
I did.
Yeah, it was pretty good.
Schnitzel.
Pretty good.
Just like the way my grandmother made it.
So I think that I'm looking forward to day 2. So tomorrow we'll have more science to share. And it's been really fun. And I hope that some of you guys, if you're listening, you'll come to our live show or to talk to us on our recording sessions. So it will be really nice to get to talk to more of the attendees.
Yeah. And well, as a reminder, we're going to have one of these every day. And you can follow us on X the whole time at @Immunopodcast or Blue Sky at immunologypodcast.com to find out what we're up to here. And visit the Immunology Podcast booth on the exhibitor floor where you can win a gift basket. Who doesn't love swag, folks?
Oh, yeah.
Check back tomorrow for another episode on day 2 of the meeting. See you then.